We're going to start with fractions, similar fractions, equivalent fractions, comparing fractions, adding, subtracting fractions, same denominators, different denominators, multiplying, dividing fractions, what is similar about them, what's different about them, and what are mixed fractions, how do we treat them like regular fractions. So basically, everything on fractions starting from A to Z, everything at all. Then we'll be adding 5 new words into our vocab journal, and there's going to be a mega test on all the 4 tables of 2, 3, 4, 5, starting from times 1 all the way through to times 20. Let's start by taking the biggest bullet first, fractions. The minute I say fractions, what comes to your mind? Most probably something, a number over a number. Am I right? So let's say 2 over 5. That's the first thing that comes to our mind when we talk about fractions, that it's going to be a number which has something called a numerator over a denominator. Well, let's take a look at this block over here that is split into 10 different blocks. So let me see. If I shade this one and this one over here, that means I'm stating that the fraction that it represents is, let's say, 2 out of 10. Would that be correct? How about this one over here? How would we represent that? That's 1 out of 5. So I've got a total of 1, 2, 3, 4, 5, and that's 1 shaded portion out of 5 shaded portions. Although, if you take a look at this part over here, the part that's shaded is exactly the same as this part shaded over here, which means, am I really talking about the same thing when I say 2 over 10 and 1 over 5? Let's say, for example, I have 6 blocks shaded over here. So that's 6 out of 10. And I've got the same portion shaded here, which is 3 out of 5. Again, I'm not talking about the same thing because it looks like the exact same area is shaded in the picture on the top and the one at the bottom. So that means I have something called similar fractions, because according to that, they're saying 6 over 10 is the same thing as 3 over 5. Which takes us to the next topic. 6 over 10 is the same thing as 3 over 5. Let's check out how. Similar or equivalent fractions. So there are two names. That we could represent this thing with, similar fractions, equivalent fractions. Now what happens is, if you, let's say I'm multiplying the numerator and the denominator by the same number, I'll choose a small number. You can choose anything, 10, 20, 15, anything. I'll choose a very small number to keep the numbers very small and manageable. 9 times 2, that's an 18. 18 times 2, that's a 36. I'll multiply by, let's say, a 10. That's 180, that's 360. I could even make it smaller and divide by a particular number. So 9 divided by, let's say, 3. So, but both have to be, numerator and denominator have to be multiplied or divided by the exact same number. So if I'm choosing 3 over here, I choose 3 over here as well. 9 divided by 3 is a 3, 18 divided by 3 is a 6. I can simplify that a bit more. 3, and I can divide it by 3 again. And that results me in 3 divided by 3. 1, 6 divided by 3, 2. So I'm talking about a half over here. And this fraction, 3 out of 6, represents the exact same thing, because if I simplify that, I again get a half. 9 over 18 represents the exact same thing, a half. 18 over 36 represents the exact same thing, a half. And 180 over 360 also represents a half. This is something we call similar fractions or equivalent fractions. The reason it's very important is because every question on fraction that you would be dealing with would require simplifying, and that's how you simplify fractions. One more concept where we need similar equivalent fractions is comparing fractions. A question like this can come up where you're asked to compare a particular fraction, 1 over 4, to the fraction in the options. 1 over 4 is being compared to the fraction in the options. But let's take a look at a bit of explanation before we start on. Now, this wheel over here is split into 1, 2, 3, 4, 5, 6, 7 parts, and this one over here is split into 5 portions. This 3 over 5 means 3 of the portions are shaded, 3 of the parts are shaded. 4 out of 7 on the right hand side means 4 portions are shaded. They look almost the same. But what if they ask me to compare? Is this greater than, or is this greater than, or are they both equal to each other? How would I compare the two fractions? Well, one of the denominators is a 5, the other is a 7. No way can I compare them. I can estimate, but I cannot compare them very specifically. To be as specific as possible, what we need to do is change both denominators and make them the same. So I've got a 7 over here. If I want to make this 7 and this 5, I want to make both the denominators the same. What I do is I multiply the 7 in here, and I multiply the 5 in here. So that multiplies by 7, that multiplies by 7. Remember, if the denominator multiplies by a particular number, the numerator has to multiply by as well. So that's 21 out of 35. This one over here, we're multiplying it by a 5. Remember, we were multiplying it by a 5. So 4 times 5 is a 20, and 7 times 5 is a 35. So we're comparing two fractions. Do you see how close they are? Oh my god, so we could never have guessed the answer to this one, even if we estimated, because 21 out of 35 or 20 out of 35, they are very close to each other. Which one's greater? Out of a total of 35 portions, 20 are shaded here and 21 are shaded here, so definitely 21 is greater than 20. When the denominator is exactly the same, I don't care about it anymore. All I care about is the numerator, the 21 and the 20 over here. So that's my answer. Let's take a look at the question on the right hand side. What they're stating is which of the following is less than 1 over 4. Which of the following is less than 1 over 4? Sometimes when a question comes up, it's just the answer's right there in your face. That's if you have a very light attitude in your mind. If you're gone too deep into the paper, it might not click. Here, take a wild guess. Which of the following is less than 1 over 4? A, B, C, D. Take a look at the options. Which one looks like it's less than a quarter? Now, if I look at the options, this over here, 5 over 88, looks very abnormal compared to the other 3 options. Because the numerator is so small compared to the denominator. That means the bigger the denominator gets in a fraction. Let's look at this. 1 over 2, 1 over 3, 1 over 4. What's happening? That's a half. That's 1/3. That's a quarter. Do you see how when the denominators are becoming bigger and bigger, the actual answer, the actual portion becomes smaller and smaller? So the denominator over here, the 88, is very big. It's huge compared to the 5 at the numerator, which is why I would opt for A. But if I do have to go into the workout, what would I do? Let's see. I've got 2 options. Either I could simplify them, either I could estimate them, like for example, either I could estimate it, or, okay, there are similar questions coming up. Let's take a deeper look into it. When the similar questions come up, they're going to come up in the exercise. For now, let's just remember, not every time do we have to work out the questions. When you look at the options, sometimes the answer is so right there in front of you, you don't have to work it out. So option A looks very small compared to the other options. we'll go into the depths of explanation of this kind of question in practice 1 and the guided practice, inshallah. Let's go through the next topic, adding, subtracting fraction. Let's review. It's a completely different case if I've got similar denominators. It's a completely different case if I've got different denominators. When my denominators are the same, like 999 over here, I just write a big 9, and I am only interested in the numerator. 3 plus 4 gives me a 7. 7 take away 2 gives me a 5. So that's 5 over 9. Nothing happened to the denominator. It's just the numerator. That's the resulting number. Whereas when you have different denominators, like in this question over here, I cannot go forth until I make the denominators the same. Now, this one's a 3, that one's a 9. Either I need to make both of them into a 9, or I make both of them into a 3. I'll make both of them into a 3. That's easier for me, because take a look at this fraction here. I can simplify, can't I? I can divide it by 3, and divide the denominator by 3. 3 divided by 3 gives me a 1. 9 divided... Oh, I see it. 3 divided by 3 gives me a 1, 9 divided by 3 here gives me a 3. Plus, I've got the second fraction, which I would just copy down, 1 over 3. Now, the question is exactly the same as this here. The denominators are both the same. I'm not interested in the denominator, I just write it down. And what I am interested in are the numerators. 1 and 1, that's a 2. So that's my solution. Let's take a look at another question. 2 over 4 minus 1 over 6. Again, I have to make them the same. I can't subtract otherwise. What I would do is simplify this. So 2 divided by 2, that would give me 1. 4 divided by 2, that's a 2. Take away 1 over 6. Again, the denominators are not the same. I'll have to change this 2 into a 6. I'll multiply it by 3. What do you say? 2 times 3 gives me a 6. That would give me the same denominator. Now, the only thing I'm interested in is the numerator. 3 times 1 is a 3. Take away 1. That's 2 over 6. I can actually simplify it and rewrite it as 1 over 3. Divide the numerator and denominator both by 2, and that gives me a 1 over 3. You could have both as answers, 2 over 6 or 1 over 3, depends, but we should know how to simplify any particular given question. We don't have anything else here. Let's take a look at multiplication. Let's take a look at multiplication. Now, when you're multiplying, we don't really care about denominators being the same at all. So addition, subtraction, the denominators have to be the same. Multiplication, division, we don't care about the denominators. They can be whatever they wish to be. That's not a problem. So what I would do is, the rule that follows is, if you've got a numerator and a denominator, that's multiplying with numerator and a denominator. What happens is numerator multiplies with the numerator, this thing here, and denominator multiplies with the denominator, this thing here. Or if you've got a numerator over a denominator times the numerator only, well, denominator stays the way it is because there's an indivisible 1 here, so it's a d times 1 actually. Denominator times 1, and the numerator multiplies with the numerator. That's the exact same rule we would follow in the first question. 21 times 2 is 42, and 3 times 7 is 21. I can simplify this. Do you see that's being doubled? Do you see that 21 doubles to give me a 42? So what I would do is divided by 21, divided by 21. That gives me a 1 in the denominator and a 2 in the numerator. That gives me, the solution is 2. Now, to make things very, very easy and not to complicate them, because we don't have calculators for the GAT, I would highly recommend that you always check if you can simplify anything at all in the given question. For example, over here, I know that 7 and 21 go in the table of 7. So remember, whenever we're trying to simplify, the numerator cancels out with the denominator. So what I would do here is divide this by 7 and divide this by 7. That's a 1 and that's a 3, right? 21 divided by 7 gives me a 3. The 3 from here just copies down. And times, I've got a 2, and the 1 from here just copies down. Anything else that's simplifying? Yes, exactly. The 3 and 3 just go off. So I'm left with a 1. 1 times 2 is a 2. There's a divided by 1, which gives me again a 2. Now, I've written this in a very long way, because in order to explain it to you, actually, it's just as simple as this. 7 times 1, 7 times 3. 3 goes off with 3, 3 goes off with 3. I'm left over with a 2. As simple as that. So I highly recommend that you simplify anything at all that you possibly can before you multiply. For example, in the next question. Let's simplify as much as we can. 3 times 1, 3 times 5. Yeah? 5 times 1, 5 times 1. Just remember, if you're planning to cancel out anything, it's the numerator that goes with the denominator. We never cancel out 2 numerators or 2 denominators. It's always one of them's got to be the numerator, the other's got to be the denominator. So I'm left with nothing over here. It's just 100 times 1 over 1, which is 100. Done. Next question. They're saying that 5/7 off in math means multiplication. Off in mathematics stands for multiplication. So 5/7 off, 49 days is how much? Now, again, 49 is a numerator and 7 is a denominator. I know I can cancel them out. 7 times 1, 7. 7 times 7, 49. The only thing I'm left with is 5 times 7. That's 35. 35 is my answer. I hope everything's clear. Let's move on to division. Division is very similar to multiplying. The only thing that we need to know is, for example, it's something divided by something else. That something else, the second fraction. Always remember, the second fraction, not the first one. The second fraction flips over. So 16 over 64 stays the way it is. The sign division changes into multiplication, and the fraction flips over. The second fraction flips over. 1 over 4 becomes 4 over 1. And then it's just regular multiplication the way you do it. Clear? So the division sign changes into multiplication sign. The second fraction, 1 over 4, flips over to become 4 over 1. And then it's just regular multiplication. We've done the table of 4. We know that this is 4 times 1, and that's 4 times 16. 16 times 1, and that's 16 times 1. Yeah, let's do this again. So the answer is 1, right? I just want to do the simplifying process again, just for you to, just to make sure you got it. 4 times 1 is 4. 4 times 16 is 16. Done. That's step 1. Step 2, I recognize that there's a 16 in the numerator and 16 in the denominator. Again, I go 16 times 1, 16. 16 times 1, 16. So I'm left with a big 1 in the end. Done. Let's take a look at the next question. 32 over 64. Divided by, so the first fraction copies down the way it is, division becomes multiplication. What happens to this? Well, 8 is the numerator, and it's got an invisible 1 underneath, right? Any number, let's say 2, is actually 2 over 1. 100 is actually 100 over 1. So I've got the denominator as 1. I'll flip it over, it becomes 1 over 8. Now, this is table of 4 again. Actually, it's table of 8 too, but because we've only done up until 4, let's follow through with the table of 4. 4 times 2, 8. 4 times 8, 32. 4 times 8, 32. 4 times 2, 8. And 4 times 16, 64. 2 times 1, 2. 2 times 2, 2 times 1, 2 again. I'm left with 1 over 16. A bit complicated. I think let's go through it again. Okay, so I'm following through with the table of, the answer was 1 over 16, right? I'm following through with the table of 4. 4 times 2, 8. 4 times 8, 32. Done. Step 1. Step 2. 8 and 2 can simplify, 8 and 64 can simplify, up to you. Let's simplify 2 and 8. 2 times 1, 2. 2 times 4, 8. Step 2, done. Step 3, 4 times 1, 4. 4 times 16, 64. Done. I'm left with no other numbers. I've only got a 1 in the numerator, another 1 in the numerator, so 1 times 1 gives me a 1. 16 in the denominator, and 1 in the denominator. 16 times 1 is 16, so that is my answer. I hope it's clear. One more thing we need to look into when we're looking into division is this. Let's say I've got a fraction divided by a fraction. So let's say I've got 1 over 4. 1 divided into a quarter. Let's write it down. That means it's 1 divided by 1 over 4, right? I'm just rewriting. What do I do now? Change the division sign into multiplication. So 1 division becomes multiplication, and the fraction flips over, becomes 4 over 1. That's equivalent to a 4. 1 times 1, 4 divided by 1, 4. Do you see how 1 over 4 became a 4? Likewise, 1 over 3 is a 3. 1 over 2 is a 2. Let's take a look at another example over here. Let's say I've got 1 over 2 over 4. What's happening all the way through is this 4 was in the denominator, and it just flipped over and went into the numerator, became the numerator. 3 was in the denominator, flipped over, went into the numerator. 2 was in the denominator, flipped over, went into the numerator. So basically, the denominator of the denominator is actually the numerator, and 2 stays where it was. That's a 2. If you are not so sure you got the hang of it, what you could do until you are fine with it, what you could do is just rewrite it like this. 1 divided by 2 over 4. Sign changes to multiplication, fraction flips over, that's 4 over 2, which is a 2. Yeah? But otherwise, the denominator of the denominator is actually the numerator. That's the concept I'm trying to get through. One last thing before we go to questions is this mixed kind of a number. Mixed numbers, if you want to add, subtract, multiply, divide, normally what we prefer to do is change them into regular fractions. So how do we change them into regular fractions? What happens is the denominator multiplies with the whole number, and then the result is added into the numerator. So it's basically denominator multiplies with the whole number, whatever you get, that adds into the numerator. That's when you get the top number. And your denominator stays the same. That's how you get the numerator, and your denominator stays the same. We look at into a few questions. So what I am supposed to do is 5 times 4, that's a 20, plus the numerator, that's a 3, over the denominator stays the way that it was, 5. So that's 23 over 5. Let's take a look at the next question just to make sure. 2 times 2, so I'm supposed to multiply, right? 2 times 2 is a 4, and then I add the 4 into the 3. 4 and 3 is a 7. Over, the denominator stays the same, 2. 2, yeah? Next, try it. 3 times 4, 12. 12 plus 1, 13. 13 over, the denominator stays the same, 3. Last number over here, we're changing mixed numbers into fractions. We're changing mixed numbers or mixed fractions is referred to as anything. We're changing it into regular fractions. Okay. 9 times 6, 54. 54 plus 2. So we're multiplying this, and then we add this over here, 56. And the denominator stays as it was, a 9. I hope the concepts are, I've reviewed them enough. Let's go to practice 1. That's in the worksheets as well. Let's take a look at question number 1. That's very similar to something we did in comparing fractions just a while ago, right? Where I was saying we'd go through the theoretical part of it. But before I go into the theoretical part of it, I'd like to attempt it the same way that I attempted the question earlier, is to sort of use your instincts and some mental math. We're looking at something that's less than 1 over 9. We're looking at something that's less than 1 over 9. Okay, which one would you pick? 1 over 9, so it's got to be something small over something a bit big. I would never go for A, and I would never go for D. I might look into this and this one over here. I'll tell you why. Now we're starting the theoretical part of it. Do you see that that's a half? 9 over 18 is a half, because if I divide that by 9 and divide that by 9, I get 9 divided by 9, 1. 18 divided by 9, 2. That's nowhere close to 1 over 9. That's like extremely small, extremely big. Half is huge compared to a 1 over 9, so that's out of the question. 6 over 56 looks okay to me. Reason being, I just want to tell you something. 1 over 9. Do you see that the numerator multiplied by 9 to give you the denominator, right? Likewise, what I could do is, if I've got a 6 over the second option, I took a 6 from the second option, B. So if it's the same as 1 over 9, what should happen is 6 times 9 should give me the denominator, 6 times 54. Because 6 times 54, 6 over 54 is the same thing as 1 over 9, am I right? 6 times 9 gives me a 54. So if it was supposed to be 1 over 9, it would have been 6 over 54. Very, very close. It's very close, isn't it? So I'm going to come back to this option. I'll go to the next option and come back to it. 5 and 36. Is it almost equivalent to 1 over 7? Because that's like 5 over 35. And I know if I divide by 5 and if I divide this by 5, I get 1 over 7. Oh, going into the other piece. Do we agree? It's 5 over 36 is almost the same as 5 over 35, and 5 times 7 gives me a 35. So that's like 1 over 7. That's still bigger than 1 over 9. 1 over 7 is bigger than 1 over 9, so I cross that out. And this one, the reason I said no to this is because it's almost like 4 over 20, which is the same thing as 1 over 5, and 1 over 5 is way bigger than 1 over 9. Coming back to option B, that's the only one I'm left with, so I would circle that. Why? Because the numerator is the same, 6 and 6. What happened to the denominator is that it's bigger over here and it's smaller over here. Remember what we said about the denominators? That as the denominator goes bigger, 1 over 2, 1 over 3, 1 over 4, what happens to the overall number? What happens to a sandwich split into 2 girls, half and half? A sandwich split into 3 people, 1/3, 1/3, 1/3, so they're getting a smaller portion. Into 4 people, they only get a quarter. Into 5 people, even smaller. So the smaller the number gets, the bigger the denominator gets, the smaller the number gets overall. Which means this has a bigger denominator, so this is a bigger number. My bad. This has a smaller denominator compared to this one over here. Because the denominator here is bigger, this number is overall smaller than this number over here. I hope we're crystal clear on this. I don't want to go on without making it clear. Yeah. So we have a 1 over 54 and 1 over 56. 6 over 54, 6 over 56. The denominator here is smaller than the denominator here, which means the bigger the denominator, the smaller the number. So this is bigger than this one here, and we said this is 1 over 9. So this number, option B, is something smaller than 1 over 9. Finally, let's move on to the next question. This will, you find it way easier, inshallah. Which is greater, x over h or y over h? Which is greater? If you pay attention, the denominators are both the same. It's this number over here, which they haven't given you any numbers, they're just representing it with letters. And x is a bigger number compared to y, which is a smaller number. Yeah? So it's basically a big number over something and a smaller number over something. So definitely the big number over something would be the bigger value. Alternatively, what we could do is, which would make things quite easy, what we could do is give them values. Here, h is 1. The value of h is 1, y is 2, x is 3. So this one over here represents x over h, which is 3 over 1, which is the same thing as 3. And this over here represents 2 over 1, which is the same thing as 2. So this is greater. Next question, question number 3, n divided by m. N is a small, okay, let's give the numbers again, 1, 2, 3. So this one is 1 divided into 3, and this one over here is 2 divided into 3. 1/3 or 2/3, which is greater? 2/3 is way bigger. 2/3 is way bigger, which is why that's your answer, h divided by m. Next question, which is greater? 1 over 12 or negative 1 over 6 minus 1 over 12? Well, guess what? I'm not even going to work this out, because this thing is going to be something negative, and that is positive. A negative take away a negative will give me something negative. That's positive, so that's my answer. Next question, again, I would not even work this out, although I know these numbers are so similar, this one over here. They're so similar, they're so simple, but I would still not work them out, because take a look, the numerators are the same. The numerators are the same. The denominator is 6, so something divided by 6 was the same thing divided by 15. Definitely, that's much bigger. Divided into 6 would give everyone bigger portions. That is very small. Done. Question number 6. Okay, looks like we'd need to do the long division over here. Remember this one from when we were kids? 7 divided by 8. You could work that out, but it's highly recommended not to use any kind of long anything in the quantitative section, division, multiplication, addition, subtraction, because there's always a shortcut and a shorter route. Because if you take a look at it, 72 and 8, what's the relationship? Times 9? Take a look at this. Same thing, times 9. Take a look at this, 54. 6 times 9 is 54. 54. 6 times 9 is 54. So do you see that they have the same relationship with each other? There's the same relationship, so they both are bound to be equivalent to each other. They are equal to each other. We'd say they're equal to each other. Sometimes students, what they do is like 1, and that's like, let's say, a 9 and a 9. Same thing, 1, 9, and a 9. Well, it does work. You can get to equals too, so very nice. Although just telling that there will be a 0 in the middle as well, if you do plan to do long division, which I would not recommend, but if you find that easier, as some students do argue they find these things easier, then that's that. Or if you simply just pick the pattern that the denominator has the same relation with the numerator on both sides, they're both equal to each other. Now, let's move on to the vocab building. Let's add a few more words into our vocabulary today, 5 of them. Let's start. So the 3 words that we are going to be doing today are, the first one's avenue. The first one is avenue. Now, you might have heard something like, there's a road and it's called, let's say, Mary Avenue. So an avenue is something similar to a street, just that it's wider. It's wider. Usually, sometimes it also has buildings on the side or trees on the side, and it's not usually as quiet as a street. It's usually something a bit busy. So it's wide and it's a busy place. So let's write a wide street. That's the meaning. So an avenue is a wide street. An avenue is a wide street, and it's not usually quiet. It's usually not quiet. Let's see, what sentence can we make with avenue? An avenue in Riyadh that has all the nice eating out places. Now, highways don't have eating out places. Streets usually don't have eating out places. So we can say an avenue has nice eating out places because it's a street wider than a street and so forth. Well, avenue also has one more meaning. And it's a way of reaching a goal or approaching to do something. For example, you might say, I tried all avenues possible to find out a resource for the GAT that I have to do soon. So that means you're working out all possible ways to find out some sort of material that could help you with your GAT. So a way of reaching a goal. Approaching to do something, let's say. Approaching to do something. Avenue, that has 2 meanings, a wide street, usually not quiet, and a way to approach something. Breezy, as you might be getting a hint, is something like, the breezy wind. So it's like windy. You could state it's a windy weather outside, or a blowing wind outside. That's breezy. The weather today is a bit breezy, so the wind is blowing outside. Well, breezy also has another sentence, which is to be a bit informal, relaxed, and lively. So it's a bit like relaxed, informal, and lively. Informal and lively. For example, I would highly recommend that you people have a very breezy attitude on the day of the exam. So you keep trying to stay lively and a bit informal so you don't get too intense and pressurized into the exam environment. So informal and lively. Her breezy nature allowed her to attempt the best GAT ever. That kind of thing. Blizzard also has something, the third word for today. Blizzard also has something to do with the weather. Well, it's not as nice as breezy. It's like heavy storm. Storm. So it's a storm with snow, and not the nice snow that's falling and you're enjoying. No, very heavy snow. And strong winds. So you can see that's quite unpleasant. So it's a storm with a lot of snow, and it goes on for a long time as well, usually, and strong winds going on. So if there's a blizzard outside, you wouldn't see any person out there. Or the blizzard destroyed the entire city. It's that kind of a storm. It's a violent weather condition outside. The event is cancelled because of the approaching blizzard. That kind of a thing. Again, it has another meaning. So we've got 1, 2, 3, 4, 5, 6. It's very nice that a single word has 2 meanings. So now you know if a single word is used, you know how to approach it in 2 different ways. Blizzard also means a series of unexpected, unusual occurrences. So it's unexpected occurrences. Series of unexpected occurrences. Series of unexpected occurrences. The audience confronted him with a blizzard of questions. Nowadays, sometimes they use blizzard in not so unpleasant tone as well. For example, this ice cream has a blizzard flavor, which means you're not expecting what's coming, but yet you are liking it. So you can use it in those terms as well. So 3 words for today: avenue. 3 words for today: avenue, a wide street, or approaching to do a particular thing. Breezy is a windy, blowy kind of weather, yet it also means to stay informal and lively. Blizzard is a very bad storm that you never want to go out in. Also, blizzard means to go through a series of unexpected occurrences. That's that. 5 vocab words. I hope jot them down in your vocab journal. Hope you've got the other 2 listed down as well. So we've got a total of 5, and let's move on to the next part, the next segment of the lesson, the guided practice. Again, as always, I would highly recommend you pause the video, give them a try, and then come back and take a look what you're managing fine and what you are doing, what you're managing fine, what you need help in. And if you think you've got a shorter cut to what I'm doing over here, I'd be so pleased to hear your answer in the comments below. Okay, let's start. Question number 1. So I do see that the denominator is 8, 5, 8, 5. I could try and make them into a 40 because I know 5 times 8 is a 40. Is there anything smaller I could try and turn it into 5 times 1, 5, 10, 15, 20? No, not really. So I have to go with this. Unless I have a breezy mindset, I'm very relaxed and I'm lively, not intense, and I do realize that, oh, why don't I add these 2 together? So 3 over 8, I added into 5 over 8. Let's do them first. 3 over 8 and 5 over 8, so the denominator, when you're adding subtracting, stays the same. And the numerator, let's just pull this down. And the numerator, 3 and 5 is an 8. Oh wow, that's a 1. Sorted. If I take a look at this one here, and this one over here, add them up together, that's the denominator is 5, and take a look at the numerator, 4 and 1, that's a 5 as well. Again, a 1. So these 2 give me a 1, plus these 2 give me a 1. I end up with getting a 2. As simple as that. Next question. We see the 25 and the 25 over here. Shall we try and do the same thing? Because although this is 11 and that's 33, I do realize that times 3 would give me this one here, because it's an 11. 11 times 3 is 33. Negative 5 times 3 is, well, 5 times 3 is 15. So I'll work with this one and this one together separately. That's 3 and 22. Denominator stays the same. That's a 25 over a 25, which is a 1. Whoa. How about the other part? This one here and this one here. What I would do is, because now I don't have an option but to make the denominators the same, I'll multiply this one by 3. I'll multiply this one by 3. So I have negative 5 times 3, 15, over 11 times 3, 33. I'll add into it this one here, which is 15 over 33. Wow. 33 stays the same, but take a look at the numerators. Negative 15 plus 15 gives me a 0, so this entire thing just crosses out altogether because it's equivalent to 0. So that is my solution. 1. Question number 3. Mixed numbers coming in. Who remembers how to do them? Denominators times the whole number, and the result added into the numerator. Let's go. 3 times 4, 12. 12 plus 1, 13. Out over 4. Plus 5 times 2. Okay, by the way, one mistake that students usually do when they see something like this is they consider negative as with the 2. No. This is one thing. A mixed number is one thing. Cannot split it. Negative applies to the whole thing. So I would there like invisible brackets over here. So if I would just keep the minus outside. 5 times 2, 10. 10 plus 1, 11. 11 over 5. Oh, the denominators aren't the same. What should I do? Try and make them the same. 4 and 5. What do I do to make them the same? I would multiply this by 5 and multiply this by 4. So I have a common denominator of 20, because 5 times 4 is a 20 and 5 times 4 is a 20. How about the numerators? 5 times 13, now that I've done the table of 5 for today, because we were supposed to, it's a table every day. 5 times 13, 65, minus from here, because addition, subtraction, together they would give you a minus sign. 11 times 4, 44. I have a 20, 64, take away 44. Normally what I like to do is I start from the 44 and I aim to go all the way to 64 in my mind again. So what I would do is, okay, 44, then I have 44 to 54, that's a 10, 54 to 64, that's also a 10, and 64 to 65 is a 1. So I have a total of 21. Again, you're doing this in your mind, sort of. So 21 over 20. Answer. Next question. Adding, subtracting once more. Oh, what did I do? Adding, subtracting once more. We're doing question number. Okay, here. We've got question number 4. We're adding, subtracting. Guess what? Similar denominators, so I would do them together. So I've got a 5 over 4 plus negative 25 over 4. And these, I would do them together over here. I've got a negative 13 over 5 plus 28 over 5. Same denominators, I'll just add them up. 5 minus negative 25. One of them is positive, the other is negative. That means I subtract 25, take away 5 is a 20, sine of the bigger number, over 4. Plus, I'm adding this thing in, which is equivalent to what? 5, the denominator stays the same. Negative 13, positive 28. I'm supposed to subtract. Opposite signs, I subtract. Again, what I would do is go from 13 to 28. So 13, 23, that's a 10. 23 and 28, that's a 5. So I get a 15, sine of the bigger number. Okay, so I've got negative 20 over 4 plus 15 over 5. Do I need to make the denominators the same again? Not really, because 4 times 1, 4, and 4 times 5 is 20. That's a negative 5. Likewise, 5 times 1, 5. 5 times 3 is 15. That's plus 3. Minus 5 plus 3. Opposite signs, I subtract. That's a 2. Sine of the bigger number. That's my answer. Next question. If you're ever feeling that you didn't get it, always just pause the video, go through it again. Don't skip to the next questions because the concepts are sort of piling on to each other. Next question. Big numbers, very big numbers. What am I supposed to do? No way am I going to multiply 22 with 3, 22 with 6, or 5 with 22. That's huge. What should I do? I've got a few options. I'll do them different ways. Check whichever suits you best. One thing that I would do is, remember terms. This is one term. That's a second term. It's the plus and the minus. That segregates the term. Remember? So from the first term, what I would do is, from the first term here, And the second term here, I'm going to take this is common, so I would take it out. 22 over 25. Taken out, bracket open. What's left in the first term? So that's gone out. This stays 6 over 11. Plus, I copy it down. I copy it down over here. I've taken that out already, so it's this one that I just copied down, 5 over 11. Let's solve the brackets. I've got 22 over 25. What do I have in the brackets? In the denominator, I've got an 11. Numerator, 6 and 5 add up to give you an 11. That's a 1. Woohoo. So I'm left with a 22 over 25 only. Solution. Otherwise, if you were planning to go by something else, let's see. If, for example, you decide to work them out, how would we go about them? Because if you plan to work them out, no way would you multiply them, right? What I would do is, here, take a look. 11 times 1, 11. 11 times 2, 22. 11 times 1, 11. 11 times 2, 22. Because there's a plus in the middle, I am not allowed to cancel something from this side and something from that side. No, no. Either you're working on this side over here, or you're working on this side over here. You don't cancel out over a plus sign, over a negative sign, or over an equals to. You never cross out over these things. You are only allowed to cross out over a multiplication sign, like we did over here. 11 times 1 and 11 times 2. Then, now that that's done, so I've got a 2 over 25 times 6 plus 5 over nothing, 1, that's also over 1. You write it, you don't write it, it's the same thing. Okay, so if I multiply them in, I have a 2 times 6, 12 over 25, plus 5 times 2, 10 over 25. That's a 22 over 25. It's up to you, whichever way clicks first. You've got two ways to solve a question like this, but the worst way that you can go about it is that you start multiplying 22 and 6, 25 and 11. The minute anything big starts to come into your mind that isn't in the times table, just remember that there's something wrong and you need to think of going by in another way. Next question. Next question, we're supposed to deal with this first and the second and then divide them. Now, clearly, the denominators aren't the same. I'm supposed to make them the same, 4 and 6. I could do 6 times 4, that's 24, make them 24. But hey, isn't 6 times 2, 12? And isn't 4 times 3, 12 as well? Why do I need to make them into 24? A big number, I don't have calculators. I prefer something small. So I'll go with 12. So I'll multiply the 6 over here with 12. 6 over here with 2, and that 2 with 2. This with 3, and that with 3. I get a 12 in the denominator. How about the numerator? That's a 10 minus, that's a 9. So I have a 1 over 12. Then I have a division sign here, 9 and 12. I can make 9, I can do this, 12 times 9, but again, I would end up getting a big number. So what I would do is, that's huge, isn't it? 108. That's huge, so I would never go with that. What I could do is try and recall the table, how you have the times table in front of you. Take a look at it, table of 9 and table of 12. Can I times it by 3 and times this by 4, and both of them together would give me a 36? 12 times 3 is a 36, and 9 times 4 is a 36. So I prefer 36 over 108, right? So I'll multiply that by 3 too, that by 4. 7 times 3, 21, minus 5 times 4, 20. That is 1 over 36, right? Next, division changes into multiplication. The second fraction flips over, 36 over 1. Oh, that's the table of 12. Or if we don't know, that's the table of 4. 4 times 3, 12. 4 times 9, 36. Second step, 3 times 1, 3. 3 times 3, 3 times 3, 9. That's your solution. The answer. Okay, done. Question number 7. Question number 7. Let's change them into, we've got mixed numbers. We need to change them into regular fractions because we don't know how to divide mixed numbers as they are. Remember, the negative has nothing to do with it unless you change them into a fraction. Let's go. 3 times 4, 12. 12 plus 1, 13. 13 over 3 with a negative, divided by 4 times 3, 12. 12 plus 1, 13 again. Over 4. Again, we've got a negative outside. Next step, copy down the first step, copy down the first fraction, division changes into multiplication, and you flip over the second fraction, which is 4 over 13. Whoa, things are cancelling out. The negative goes with the negative. 13 goes with this 13, so I'm left with 4 over 3. Answer. Done. Question number 8. Mixed numbers again, yet again, yet again. Mixed numbers, I would simplify as much as I can because I see a 4 over here, right? 3 times 1, 3 times 4. That's a negative 4. Times 3 times 4, 12. Plus 2, 14. So I've got a 14 over 3. I've got a division sign, but let me work this out first. That's 9 times 6, 54. 54 plus 2, 56 over 9. 56 over 9, okay. So I'll change the sign into multiplication, flip over the fraction. So I flip over this fraction, and that's what I get. And hey, things are cancelling out. 3 times 1, 3. 3 times 3, 9. 14 and 56, table of 7. 7 times 2, 14. 7 times 8, 56. Oh, things cancelling out again. 2 times 1, 2. 2 times 4, 8. Things cancelling out yet again. 4 times 1, 4. 4 times 1, 4. So I'm left with only a negative. Everything else is 1 and a 3. That's my solution. Just make sure when you are simplifying that one of the things is numerator and the other thing is denominator. Don't sometimes, when it looks a bit, when you're simplifying, things do get a bit messy and you might by accident cancel the denominator with the denominator, which is a big no-no. It's only the numerator that cancels out with the denominator. Next question. Again, fractions, we're multiplying, dividing fractions. The minute I look at this over here, I see a 6 over 5, division becomes multiplication, 6 over 2. Right? Division becomes multiplication, fraction flips over. That's a 36 over a 10. Multiplication, copy it down from here. I had 100 over 36. Woohoo! 36, 36, they cancel out each other. The 0 goes off with this 0. You're left with a 10. By the way, zeros can go off with each other. For example, I have a 100. Isn't that the same thing as saying 10 times 100 over 100? This is 10 times 100, isn't it? So I can just say 2 zeros go off with the 2 zeros. We'll look into it later on. So question number 9, hope everything's clear. Let's move on to question number 10. Which of the following are in ascending order? Which of the following are in descending order? Descending order. So that means you're starting from something big and becoming smaller. Descending order. So we want to start from something big. We've got four options. Let's take a look at them. 4 options. Are they fitting in? Let's see. Oops. Okay. 4 options. We're starting from, we want something to go from big to small. Okay. If you take a look at this one, the first one, give it a try before you look at my explanation, by the way. If you take a look at the first one, this is a third, and it goes all the way to becoming 6 over 7, which looks like almost a whole thing. 6 over 7 is almost like a whole thing, right? 1/3, for example, would look like this. oh, 6 over 7 is like this. Six parts are shaded, and just this is left over. So do you see how this is so small, and that's becoming bigger and bigger? Is that what we're supposed to do? No, we're supposed to go from in descending order, so something big to something small. So that goes out the window. A. Even this one here goes out. So that, by the way, here, even the third one just goes off. They're exactly the same, right? No, no, no. Let's take a look at the last one. It has to be the last one, but here, this is something big, very big, and this is something small. So you're going from this one to this one here. And in the middle, you've got different options. Now, as a matter of fact, we don't have the brain and a calculator to be able to work out each and every one of these fractions when you're sitting in the GAT hall, right? When you're sitting there, you don't have the time, neither do you have the time, to be looking into all of this. Which means what you're supposed to do is the fractions, the number of fractions, oh my god, they've got like 6 times 4, 24 fractions over here. If they take a toll on you, if the fractions, you look at them, you go like, oh my god, I mean, so many numbers, I don't know what to do. Then that means most probably you would not get the solution. But if you keep a very breezy mindset, it would take straight away. That's so small, that's huge, that's so small, that's huge. I'm not supposed to go in that order. I'm supposed to go from something big to something small. This is the only one that's going from big to small, although I didn't even look at the middle numbers because I really haven't got that kind of time. Only 1 minute per question, right? So always remember, keep a very light mental attitude because a question like this is not even meant to be solved. You can't solve it. Okay, I can't solve it. I mean, no one can solve it. So yeah, next question. Oh, which of the following is greater than 3 over 4 and less than 5 over 6? Which of the following is greater than 3 over 4 and less than 5 over 6? 3/4. I'll just draw a diagram to sort of, for you to have an idea. This is 3/4. Yeah? 5/6 is something like this. 1, 2, 3, 4, 5, 5/6. This is 5/6, and this is 3/4. So we want something in the middle in here. Half, isn't that less than 3/4? Goes out. 2/3. Okay, half is like this. 2/3 is like this. It's not even 3/4. To be 3/4, this should be folded as well. Goes out. 4/5 and 9/10 is something that I'm looking at. I'll try and make both the denominators the same. That's the same thing as saying 10 and 8. I'm making the denominators the same so I can compare them. I have an 8 over 10 here and a 9 over 10 over here, and what I'm comparing it with is the 5 over 6 because it has to be somewhere in between these two. 5 over 6. Again, shall I try and make the denominators the same? I can times this by 3, make them 30. That's times 5, times 5. That's times 3, times 3. Yeah, now everything's 30. It's a 30 over 27. It's a 30 over 24. And this one is a 30, 5 times 5, 25. It has to be less than this. Remember, it has to be less than the 5 over 6. So this one's lesser because you would have a 25 over 30 over here. 25 over 30 is this one over here. This is greater than, this is the one that's smaller, so answer is part C. Next question. If 1/3 of the liquid content of a can evaporates on the first day, okay, so the first day I had a complete liquid can filled with liquid. The first day, 1/3 of it evaporated, which leaves me with what? I can't subtract, I have to make the denominators the same. That's 3 over 3, take away 1 over 3, that's 2/3, yeah? That's 2/3. So they're saying 1/3 of the liquid of the content of a can evaporates on the first day, and 3/4 of the remainder evaporates. So this is what the remainder is. They're saying 3/4 of the remainder. 3/4 of the remainder evaporates the next day. 3 and 3 cancel out. 3 and 3 cancel out. That leaves me with 2 over 4, which can be simplified. Divided by 2, which is 1 over 2. 1 over 2. So that means this is what evaporates on the second day. This part is gone. This part is gone from this one over here. From this one here. This is what I have left over on day 1. And day 2, half of it goes off. Half of it goes away. That means what I need to do is, out of the 2/3, half is gone. Again, I don't know how to subtract. I can't subtract. Maybe I have to make the denominators the same. Times it by 2, times it by 2, times by 3, times by 3. So my denominator is 6. So 6 and 6 here. Numerator, 2 times 2, 4. Take away 1 times 3, 3. That's 1 over 6. 1 over 6 is the leftover. 1 over 6 is the leftover after the 2 days. So that was the workout for day 1. Whatever was left of day 1, a portion of that was gone away on day 2 as well. So we worked out day 2 here. Once we worked out how much of day 2 was gone, we said, okay, so what was left on day 1, take away what was taken away on day 2. That gives us our answer. Next question. A mixed number again. So what they're saying is 2/3 of the cakes are left over at Amani's birthday party. So 2/3 are left over. So we've got 2 wholes, and from the third one, we've got 2/3 left over. 2/3 cakes of her party is left over. She splits them into 4 equal parts. That means we've got 2/3, and she splits them into 4 equal parts. How much does each get? So we've got 2/3. Change this into a fraction. 3 times 2, 6, 6 plus 2, 8, 8 over 3. Division sign becomes multiplication, flips over, 1 over 4. That's it, that's your answer. Just simplify first, that's 1 and that's 2. So she each gets 2/3. Four friends, right? A 4 friend each gets 2/3. That's done. Question number 13. Question number 14, which is greater? Now, because there's the brackets over here, and there's multiplication inside, and there's multiplication outside, it's as good as saying there are no brackets. It's as good as saying there are no brackets. So I might as well just say it's multiplying, and it's multiplying. So they're saying which is greater, 20 or this thing over here. Now, very luckily, I can cancel out a lot of things. Denominator, numerator, denominator, numerator, denominator, numerator. So I'm only left with 3 numbers. 4 times 5, 20, 20 times 4, 80. So I've got an 80 over here and a 20 here, which is greater. Most certainly, the answer on the right-hand side. Next question, question number 15. Now, they're asking you to add the 3 fractions, but the denominators aren't the same. How do we add them on? I have to make them the same. I'll multiply this with 1, 2, 3. So I've got 2 zeros over here. I'll multiply by a 10, by a 10. 1 0 here, so I'll multiply by a 1, 2. 1, 2, 100. So all my denominators are 1,000. 30 over 1,000. 2 zeros from here, 1 more from here, 1, 2, 3. Plus 3 times 100, 300. Over 10 times 100, 1, 2, 3. All the denominators are the same. I've got a 333. 333 over 1,000. That's my answer. Next question. Oh, remember the denominator of the denominator thing? Remember we did this in the lesson? That's a 4. The same concept is being used over here. So basically the denominator of the denominator becomes the numerator. Remember? So it's like 3 times 7 over 3 plus 2 times 3 over 2 plus 1 times 3 over 1. 2 goes off with the 2, 3 goes off with the 3. I'm left with a 7 plus 3 plus 3. That's a 13. Solution. Next question, number 17, which is greater. Now, this is those kind of numbers. I could try and make the denominators the same, but I'm actually not going to bother going into all of that because I do see this as like a 3 point something. Actually, let's not write denominator decimals because we haven't covered that topic yet. That's almost like 12 over 3, right? That's like almost a 4. And then I'm taking away from it, let's say 6 over 5. That's like almost like 5 over 5. That's like taking away 1 from it. So I have roughly 3 over here. I have 3 on the right-hand side. On the left-hand side, this is less than a 1. This is also way less than a 1. So both of them together are like less than a 2. That's 3, and that's less than a 2. Certainly this is bigger. If you think, try and I would recommend that you go by it this way, because some questions are so off track, like they're so not close to each other that you could try estimation. But attempt them, but if you feel not comfortable, you can go with the theoretical way, which is making the denominators the same. You can go by that way as well, no problem. Next question, number 18, I would recommend that you go by it yourself. I'll just give you the answer. That's 13 by 4. That's 8, that's 65. Answer. I think you can manage this on your own. This one here. Now, it's 1 over something, or a 4. They're saying which is greater. What I would do is just deal with this first. So let me try and work out how much is this. It's 1 over 4 plus 1 over 2. If the denominator is the same, so I have a 2 over 4 plus 1 over 4. The denominator is the same, 2 over 1. 2 plus 1 together gives me a 3. So I've got a 1 over 3 over 4. Remember how we could write this? Remember how this goes to the numerator? So it's 4 over 3. Is that greater or is 4 greater? Oh, way bigger. That's like almost like 3 over 3 is a 1, right? And that's a bit bigger than that. So definitely 4 is way, way, way bigger. Let's go to the next question. We're looking at question number 20. 2 more to go. 20 and 21. 2 more questions to go. 20 and 21. Question number 20 is so easy. Don't get overwhelmed with the numbers. Sometimes these numbers are not too big. Sometimes they could end up saying like 156. So writing 156 over 321. Oh, what's happening? Let's say this. We're looking at this one first, then I'll be going to this. 3 over 2 divided by 3 over 2. Do you see that it's like the same thing? It's like this same number divided by same number 3 over 2. That's just like saying just 1 divided by 1. It's the same thing over the same thing. 10 divided by 10, 1. A million divided by a million, 1. So this is a 1 times 3 times 3, 9, 2 times 2, 4. Numerator with numerator, denominator with denominator. Again, same thing. 3 over 2 divided into 3 over 2, 1. So your answer is 1 times 9 over 4 times 1. That gives you a 9 over 4 only, right? So what I was trying to say was don't get overwhelmed with the numbers. Sometimes they might give you like huge, big numbers, and what they're expecting you to do is like, stop being greasy. They're expecting you to stop being greasy about it, and for the big numbers to take a toll on you. Actually, take a look at this. It's 156. Out of 213 divided by the exact same thing. 1, they just cancel out each other. Again, they just cancel out each other. It's a 1. So the only thing that you're looking at this part, which is 9 over 4, just like in this question over here. So make sure you maintain a breezy attitude. If a question comes up that you don't know, you tell yourself to relax, sit back and, take 5 seconds and then come back to it. Maintain a breezy attitude. A and B are both positive numbers, which is greater. Now, the easiest way to go by this is to pick any two numbers. Let's say 2 and 3. 2 and 3. So 1 over 2 plus 3, or 1 over 2 plus 1 over 3. 1 over 2 plus 3 is like 1 over 5. So that means one whole thing is split into 1, 2, 3, 4, 5, and just one of them is shaded. That's what the 1 over 5 is. Whereas when you've got this number here is like a half, and that here is, let's see here, 1/3. Do you see how big these two are compared to this small one over here? Do you see how this is so big? The option on the right is so much bigger than this one. So basically the idea is whenever you're adding fractions, the smaller, remember we said the smaller the denominator if it's a 2. This is a 3. The bigger the number is. This one together is a 5. A big denominator means a very, very, very small fraction. So let's hope we can remember that. Let's go into the last segment. We're taking over an hour today. Looks like it. No problem, because fractions are just that important. Table check. We're going to race against each other. This is there in your worksheets. We're going to race against each other. And mind you, I'm writing on a tablet, which means I'd be very slow compared to normal speed, which means you have more time. Which means you have more time. And the idea is that if you're not keeping up with the tables now, it's going to get difficult by the day. Reason being, what we're doing in the first week is just reviewing previous information. And the upcoming weeks, the upcoming 3 weeks are going to get very overwhelming, especially because there will be a lot of verbal material coming in as well. So I'm insisting you very much to make sure you stay up to date with your tables. 2, 3, 4, 5. Let's race against each other. You can keep your timetable in front of you to take help, sneak peek now and then, but you'll be honest with yourself how much you know, how much you don't know. Let's go. Let's start. Race against me, against you. Let's start now. 1, 2, 3, 4, 5, 6, 7, 8. Okay, table of 1, done. Table of 2. It's very easy when you write the table straight away because you can very easily count on as well, so no problem about that. 28, 30, 32, 34, 36, 38, 40. I'm sorry if I'm bothering you. Put it to mute and go do your stuff. 3 times 3, 1, 3, 6, 9, 12, 15, 18, 21, 24. Pick a mistake if you can. If I do a mistake, I'd like it if you can pick it and then post it in the discussion forum underneath. That would be great. 52, no, 42. 42, 45, 48, 51, 54, 57, 60. Table of 3 done. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 68, 72, 76, 80. That's done. Table of 4. Table of 5 is easy, easy peasy. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Done. I'm done with the tables. Hope you are doing. I really hope you finish before me. That's it. So if you're okay with the tables, well and good. If you're not, please I insist you get serious about them now, because the upcoming weeks will be a bit more overwhelming than what we're doing now. That's it. Let's wrap up, and I'll see you in the next lesson. Till then, take good care and keep shining.